Hi, today we're going to be going through constructing a McCabe Thiele diagram on Excel. So we're going to be going through a bit more of a rigorous approach than the previous videos on the channel with the simplified approach, so make sure to check out that if that's what you're after. But today we're going to go through in a full approach. Just to let you know, we're going to be starting assuming you've already got your VLE, and you can check other videos out on how to construct that. What I'm going to do is I'm just going to talk you through the steps and then we're going to go through them quickly. So you can see I've got my McCabe, my VLE. We're going to generate this McCabe Thiele diagram. So what that's done is using these plates that I've got set up here. So you can see plate 1 down 1, plate 2, and then we're just going to step off this diagram all the way down. So we're going to be using these into a scatter diagram to generate that. And how we're going to be doing that is we're going to be doing it from this tall ball model and ball model. And what this is going to do is it's going to solve our plates for us. So the first step that we need to go through is we need to go through adding a equation of the line onto this equation here. So if I just change the pressure of the system, then that's going to generate a new equation for us. So it's not already solved. Okay, brilliant. And then the first step we need to do is we need to insert a trend line for this equilibrium line here. So add this here, we need to go to polynomial. For me, a fifth order polynomial will work. If I display this on the chart, you can see it's r squared equals 1. You may need to use a sixth order if you want to get it a bit more accurate. Once that's accurate, then you can then drag this down, and we'll be copying this into the cells just down here. So you can see here I've got equilibrium and I've got A through F. So we're just going to be filling in these coefficients into these boxes here. And 8 point. We're not going to be worrying about the plus and minus signs because we'll sort that out with the equation in a second. 0.959, 4.0886, 0.1105. Okay, hope that's accurate for you guys. Well, yeah, it looks about good. So the next step is we're going to be filling in this tall and ball line. So we just want them in the form of y equals mx plus c, which is what we've got these graphs over here for. So you can see that I've got my tall line and my ball lines just mapped up from the 2 points, the start and end points of them. And again, you can see that I've got this filled in already. Worth noting, I've just renamed all these cells A, EA, B, C, etc. And then T for tall, B for ball. You can see right, so once we've done that, then we can move on to the next step, and that's creating this model to solve. So what we need to do here is start with our draw point, so we know it's 0.95 from the VLE, and then we just need to work out what value of y2 and x2 we need. So y2 is going to be the target value here. So we know that for the plates we need to remain horizontal, so we're going to know this is going to be equal to 0.95. We just need to find out what value of x to put in for that. So you can see this equation. This is a polynomial equation for these coefficients. So just input an x2 into that. So what we can do is we can go quickly to data, we can go to whatf, goal seek, and then we want this to be a value of 0.95 by changing value of x2. So you can see this solve that. So essentially that's what we're doing all the way down for each plate across here. And then likewise for the down variables, we're starting these points x1 and x2 are always the end points of the plate or down before. And then for this down 1, we've got the x value is going to remain constant because we know we're going vertically up and down the graph. And then the y value is the equation of the line. So you can see this is in the form y equals mx plus c. Okay, so that's all you need to do for this solving part here. what I'm going to do is I'm just going to press this place button, and it's going to solve everything for me. And then what we need to do is just start filling this in on our diagram. So you can see I've got these all set up as 0.95. So for plate 1, we just want to fill in this plate 1, x2, y2. Down 2, we just want to make it, down 1, sorry, need to make it equal to those. Plate 2. So what we're going to do is we're just going to stick to the tall section for now. Down to, oops. There you go. So just fill those in. These equal the value of the one before. Plate 3. Down 3. Plate 4. And we'll get down 4 involved. So you can see with down 4 here, we've got to this point where, as you can see at down 3, we've got an issue. So don't worry about these other graphs. These are the ones we haven't sorted yet, plate 5, etc. So you can see that we've reached an issue here where we're still going off of, and this orange line represents it brilliantly, the toll. So we're actually at this point of down 3, we need to make sure that we're switching to the ball. So all you need to do is you've got this all set up. The only change, this is still exactly the same, the only change is this, which is an if statement. Essentially you just need to write y equals mx plus c for the ball. All I've done is add an if statement to say that we can't go below this x equals y line. So we need to know that at plate 3, down 3, sorry, we want these values to not be reading off the ball section, we want them to be reading off of the tile section. So if we just bring these across here, just drag that across like that. Alright, and we resolve. Okay, brilliant. So we know that from down 3, we're going to want down 3 to be equal to the ball sections. So you can see that's working out now for us. So we'll just continue on with these plate 4, x2, y2 in the ball, down 4 also in the ball, plate 5 we've not reached it yet, so plate 5 what we know is going to be in the ball section as well. And we always end on the down, so who knows, this is going to be down 5. That's right. Okay, brilliant. So we can see that our McCabe Thiele diagram is all constructed now. So that's brilliant. That's all the steps that you really need to follow. One thing that is worth showing you is if we go into design mode here, I've got a macro, this plates, which I used, and that's just doing this solver just automatically for us every time. It saves a lot of hassle. So you can see I've got this run sheet 3 test macro, and this is the macro right here. So all I've got is we're saying that we want to goal seek the value of y2 to be equal to y1 by using x2 as the change in cell, and that's for the rows between 47 and 60. So you can see 47 here is just the start point, and 60 is the end point here. That's all there is to it, so hopefully you found that useful. Let me know if you have any questions, and that's it. Bye.